In this tutorial, we are going to discuss on runtime environment. So, what is a runtime environment? It is a state of a target machine which may include software libraries, environment variables, etc. to provide services to the processes running in the system. That is, we have a certain processes that are running in the system. Okay, and this runtime environment will provide services to the process. Okay, and what are the services they provide? They provide software libraries, environmental variables, etc. So that is runtime environment. Now first term is procedure. Now procedure can be defined as a declaration that associates an identifier with a statement. Okay, so what is the identifier and what is the statement? Procedure name is the identifier and procedure body is the statement. So procedure definition is a declaration which associates an identifier with a statement. Identifier is the procedure name and procedure body is the statement. So this is an example. Procedure read array where body is variable I equal to integer begin for I equal to 1 to 9 do read a of I end. So this procedure name is the identifier and procedure body is the statement and whole thing is the procedure definition. Now next is activation tree. So when an execution of procedure occurs, it is called activation of the procedure. So each execution of procedure is referred to as activation of the procedure. And what is the lifetime of this activation? It's the time taken by the procedure to execute. Okay, so lifetime of an execute activation is the sequence of steps present in the execution of the procedure. So if A and B are two procedures, then their activations will be non-overlapping. That is, when one is called after another. Okay, so once A finishes, then only B's execution will begin. So for nested procedures also this is the case. Nested means one procedure will be written within another procedure. Now when a procedure is recursive, you know what is a recursive procedure, right? The same procedure will be called again and again till a condition for exit will occur. So in that case, if a new activation begins before an earlier activation of the same procedure has ended, it is called a recursive procedure. So before ending of the one activation, another activation will begin. So activation tree will show the way control enters and leaves activations. So that is where we use this activation tree. So properties of activation trees are 1. Each node represents an activation of a procedure and root always shows the main function. And node for procedure X is a parent of node for procedure Y. That is, X is the parent and Y is the child if and only if control flows from X to Y. Okay, so if the control is flowing from procedure X to procedure Y, then X will be made as the parent node and Y will be made as the child node. So these are the properties of activation. This is an example. And this is a recursive function quicksort. So this is the main function. So there are two procedures, read array and quicksort. Within quicksort, what will happen? Int m comma int n. First we will call for partition. Okay, so we know that when we do quicksort, we will find a pivot key, then we will divide the array into two, before pivot and after pivot, and then we will again call the quicksort function. So a partition mn, then quicksort of mi minus 1 where I is a pivot, and again quicksort of I plus 1 n. So this is the corresponding activation tree. So main function I have made it as a root, then read array is the first function, then quicksort is the second function, which is called within the main function. So I have made it as a children nodes of this main function. Then when quicksort is called, what is done? Partition is called, quicksort is called, and quicksort is called. So that is why I have given partition of 110. Then mn mi minus 1. So 1 to 4, I have taken 5 as the pivot value, then 6 to 10. And this procedure will continue. So first main function as the root, then main calls read array and quicksort. Quicksort in turn calls partition and quicksort again. Now this is how activation will occur. First activation for main will occur when A is called, it will create activation of A. When B is called, activation of B will be created. So when a control transfers to B for creating activation, what will happen? This will get pushed into the stack. Okay, so before going to A, activation record of main is created. Then when A is called, activation record of A is created. Before going to B, activation record of main and A is pushed into the stack. Okay, before going to C, activation of main and B will be pushed to the stack. So continue. So that is where the stack becomes helpful for mainly in the case of recursive procedures. Okay, so control stack or runtime stack is used to keep track of live procedure activations. Now, a procedure name is pushed on the stack when it is called. Okay, when activation begins, it is pushed to the stack, and when it returns, act is popped. And information needed by a single execution of a procedure is managed using an activation record. And when a procedure is called, activation record is pushed to the stack. As soon as the control returns to the caller function, the activation record is popped. That is how the control will keep track of this nested procedures. Then the contents of the control stack are related to path to the root of activation tree. When node n is at the top of the control stack, stack contains a node along the path from n to root. Okay, when n is at the top, then the stack will contain all the nodes along the path from n to root. So this is an example. So we have the activation tree of quicksort here. So when we take activation of QS44, how I'll reach QS44 from main quicksort 110, then quicksort 14, then quicksort of 44. So each time first main will be activation of a main will be created, it will be pushed to the stack. Then activation of quicksort 110 is created. When this is called, it is pushed to the stack. When this is called, this is pushed to the stack. Okay, till when QS44 is activation is created, it is pushed to the stack. Thus, if I have a node at the top of the stack, I will have a path from root to that particular node in the stack. Then scope of a declaration. This is nothing but similar to that of a scope of variables. So we know that variables can be either local variable or a global label variable. Similarly, it is here also a declaration is a syntactic construct that associate information with a name. Okay, and declaration may be explicit such as variable I equal to integer. That is, I is a variable of data type integer, or it can be implicit declaration. Portion of a program to which a declaration applies is called scope of the. Next is binding of names. If each name is declared once in a program, the same name may denote different data object at runtime. This happens in the occasions of polymorphism, right? So in the case of polymorphism, depending upon the arguments, the execution of different functions can occur. So this is called binding. Okay, so data objects corresponding to a storage location that hold value. Now, these are two important terms, environment and state. Term environment refers to a function that maps a name to a storage location. Okay, a name of a particular variable is associated to its storage location in term environment. Then the term state refers to a function that maps the storage location to value held there. Okay, so environment means a mapping of a variable to the storage. State means mapping of storage to the actual value. So when an environment associates storage location S with a name X, we say that x is bound to s. That is, x variable is bound to the storage location s, and this association is referred to as binding of x. So this is a notation. When the name is binded to the storage, it is called environment. Storage is binded to value, it is called state. So please go through the tutorial and understand the concepts.